Matthews Gatos here. Welcome to Chapter 4 Quadratic Equations, Lesson number 2. In this lesson, we're going to cover factoring, solving by factoring. But before we begin that, I want to review what we did in Lesson 4.1. So let's start with this review question. The quadratic equation 2x squared plus 15x plus p equals 0 has a solution of x equal to negative a half. The value of p to the nearest whole number is, we have to figure out. So first of all, we have to remember what a solution is. So remember from yesterday's lesson, a solution is a point that the graph passes through, and it is the x-intercept. So that's my very first tip for you. If x equal to negative half is a solution, then the function passes through that point, negative a half, 0. It's an x-intercept. So what I'm going to do is I'm going to plug in x as negative a half and y as 0, and then solve for the p-value. So I have 0 equals 2 times negative a half squared, using brackets for my substitution, plus 15 times negative a half plus p. And then I'm just going to solve that equation. So I can put what I've already done into the calculator in terms of the numbers. So I have 2 times negative a half in brackets plus 15 times negative a half. So I'll put that into my calculator and I get a value of negative 7. So right now what I have is 0 equals to negative 7 plus p. So this whole thing on my calculator was negative 7. So then I just have to add 7 to both sides. That's gone. And p equals 7. Okay, in this example here, we have a quadratic function f of x, and it has one real 0, and that 0 is x equal to c. So the following statements are made about this. Statement number 1, and we have to determine which ones are true or false. So statement number 1, x equal to c is a solution of the function f of x. So if it has a 0, the 0 is a solution. So this is true. Okay, x equal to c is a root of the equation. That is also true. So remember, we talked about this in 4.1. Zeros, solutions, and roots all mean the same thing. So this is also true. Okay, x plus c is a factor of the function. This is false. Here's why. If this is the solution, right before we set the factor equal to 0, subtracting c from both sides, I would have had x minus c equal to 0. So before I set it equal to 0, I would have had this, x minus c. So x minus c is the factor. So roots and factors have opposite values, so that is false. Okay, it says C0 is an x-intercept of the function. That is true because zeros, solutions, roots, and x-intercepts all mean the same thing. And then the last statement that C0 is the vertex, that is false. It has to be the x-intercept. So the statements that are false are statement number 3, and statement number 5. Okay, so in this lesson here, we're going to look at factoring quadratic equations. So we're going to look at a variety of ways of factoring them, solving them, and word problems. So what does it mean to solve something by factoring? What it really means is, first of all, you're going to have to set the equation equal to 0 and then break it down into its binomial factors. So you're going to factor the quadratic, meaning you're going to break it down into its factorization and then set each factor equal to 0 and solve. So my tip for you is that once you set it equal to 0, you're going to use the 0 principle. Here's what the 0 principle says. If I have two values, a and b, and they multiply to 0, then a can be 0, or b can be 0, or they are both 0. That's why we set it equal to 0 and solve. The reason we're setting it equal to 0 is because it's an x-intercept. So once we've set each factor equal to 0 and solved, we state the answer and check the answer in the original equation. Check, most important part of solving. So remember, solving a quadratic equation by factoring is the same thing as finding the x-intercepts algebraically. Now, x-intercepts have coordinates of x and 0. So this is my x value, which is my solution, and this is my y value. So since y value for an x-intercept is 0, that's why we set the factors equal to 0. Okay, whichever method of factoring you use, there was a variety of them in 10C. We have videos of all of them on D2L. Regardless of the method that you use, always check for a greatest common factor first. Okay, let's look at this example here. So I want to solve this one here by factoring. So my tip for you here is when a equals to 1, the number in front of x squared equals 1, look for two numbers that multiply to the c value, which is your last value here, and also add to your b value, paying attention to the signs. So I want to find two numbers that multiply to a negative and add to a negative. So first of all, with integers, if they multiply to a negative, I know one factor is positive and one factor is negative. Okay, and then I'm just going to look for two factors that are 4 apart. So the factors of 12 that would work would be 6 and 12. 2. 6 times 2 is 12, and 2 take away 6 is negative 4. So I know that the negative one is going to be the bigger one since this is the answer is negative. So this is going to be my negative 6, and this one here will be my positive 2. So as soon as you find the numbers, just do a quick check. 2 times negative 6 is negative 12. Yes. 2 plus negative 6 is negative 4. Yes. So I know I have the correct factors. So once I find my numbers, the only way I can get x squared is x times x, and then I just put my factors in each bracket in either order, doesn't matter, and that is equal to 0. So I have a solution that x plus 2 can equal 0, or x minus 6 can equal 0. So here, subtracting 2 from both sides, I get x equals negative 2. Here, adding 6 to both sides, I get x equals to 6, and those are my solutions, which of course I would then go ahead and check. So I just want to show you this check here, and I'm not going to do this for every question, but I want you guys to check it all the time. So put your original equation into y1. Then we're going to start the table at our solution. So to start your table, you're going to do second window, and you're going to start it at what we thought our first solution was, which was 6. Then you go into your table, second graph, and you can see when x is 6, y is 0. So that's good, and that tells me that x equal to 6 is a solution. Let's check the other one. So the other solution I thought was negative 2. So again, I'm going to go into second window, start my table at negative 2. In my table, I see negative 2 makes it equal to 0. So I know x equal to negative 2 is a solution. Okay, so you're checking in the table. The check always happens in the table. Okay, let's try this one here. We want to solve this by factoring. So the first tip I have for you is that the positive leading coefficient, that's the number in front of x squared, that needs to be positive to solve by factoring. So what I'm going to do is I'm going to add 2x squared to both sides and subtract 12x from both sides. So just give myself a little bit more room here. So I'm going to add 2x squared and also subtract 12x. And I do that to both sides because it's an equation to maintain the balance. So here, a positive and negative cancels. Positive and negative cancels. I'm left with 0 equals 2x squared minus 12x plus 16. Okay, so now that I have that factor, I'm going to follow my very first rule, which was to always look for a greatest common factor. So I see it has a greatest common factor of 2. So I'm going to factor out the 2. So 2x squared divided by 2 is x squared. Negative 12x divided by 2 is negative 6x. And 16 divided by 2 is 8. So now I'm good to factor, so I look for two numbers that multiply to the last number, positive 8, and add to the middle number, negative 6. So integer rules tell me if I multiply to a positive and I add to a negative, both my numbers have to be negative. So the two factors should be 2 and 4. But again, as soon as you find your numbers, always check. So negative 2 times negative 4 is positive 8, and negative 2 plus negative 4 is negative 6, so I know I'm correct. So to factor it, I'm going to keep my 2 there. And then the way that I factor x squared is x times x, and then I just put these two numbers, minus 2, minus 4. Okay, so now that I've factored it, I'm going to set each factor equal to 0 and solve. So my first factor, I'm going to group the 2 with the first factor. So 2 times x minus 2 equals 0. And then my second factor is just x minus 4. So on this one here, I'm going to divide both sides by 2. 2 divided by 2 is 1. And I'm left with x minus 2 equals 0. And then I'm going to add 2 to both sides, and x equals 2. Over here, I just add 4 to both sides, and then x equals to 4. So my solutions are 2 and 4. Okay, in this one here, I'm going to solve this one by factoring. So I want to set it equal to 0. So I'm going to subtract 21 from both sides. So I get 0 equals 6x squared minus 5x minus 21. Now, this is the first time we've seen where a is not 1. So when a is not 1, you're going to look for two numbers that multiply to a times c, negative 126, and still add to the middle number. So when I get into bigger numbers, sometimes it's a little harder to see the factors. So I'm going to show you a little trick that you can use on your calculator to help you find factor pairs of negative 126. So what I do is I go into my calculator and I take what product I want, negative 126, and I divide it by x. I'm dividing it by x so that I am going to get all of my factor pairs of negative 126. Now, I go into my table, and obviously I have some decimals. I don't look at the decimal numbers. I only look at the integer values. So this is giving you all the factor pairs of 126 negative. So you can keep going down the table, but I'm just looking for the first one that adds to negative 5. And scanning through the table, I see that this one here is the golden ticket, 9 and negative 14. So I know that positive 9 times negative 14 is negative 126. And I also know that positive 9 plus negative 14 adds to negative 5. So now that I've found the numbers, you guys can factor in whatever way you want. Some of you do decomp, some of you do inspection, however you want to do it. I'm going to go back to the box method that we used with completing the square, since we already covered that. So I'm going to put my first number here. I am going to put my last number, the negative 21, here. And I'm going to put the factors that I just found in any particular order, positive 9x and negative 14x there. And then in doing so, I just have to go ahead and factor. Oh, and I made a little boo-boo. This is not x squared, it's 6x squared. Okay, so first number 6x squared here, last number negative 21 here, and then your two factors go in any order there. So now I'm just going to factor by GCF. Okay, so the GCF between 6 and 9 is 3. The GCF between x squared and x is 3x. So as soon as I've done that, I can just do 3x times, I know 2x is 6x squared. Okay, so go to this column here. The GCF between 9 and 21 is positive 3. So, and I can just check 3 times 3x is 9x, that's good. And then here, 3 times what number gives me negative 21? Well, that's a negative 7. So I can just check everything here. 2x times 3x is 6x squared. 3 times 3x is 9x. 2x times negative 7 is negative 14x. And 3 times negative 7 is negative 21. So I know I factored it correctly. And now I just have to put it together. So my factors are the length and the width. 2x plus 6 multiplied by 3x minus 7. So geometrically, really when you factor, you're just finding the length and the width given the area of the rectangle. So I've set each factor equal to 0. And again, do whichever method you feel most comfortable with. So 2x equals negative 3, and then divide both sides by 2, and I get x equals to negative 3/2 is my first solution. And over here, add 7 to both sides, and I get 3x equals 7. Divide both sides by 3, and I get x equals 7/3 as my second solution. So those are my solutions, negative 3/2 and 7/3. Okay, let's look at this one here. So this one here looks complicated, and the temptation is to start to expand in group-like terms. But if you notice, I have an x plus 2 that's squared and an x plus 2 by itself. So my tip is we're going to factor this by substitution. So instead of using this big polynomial, I'm going to substitute d for x plus 2. And instead, I'm going to factor 6d squared minus 7d minus 3. And then in the end, remember that I have to substitute it back. Okay, so this is always a good solution, is to factor a simpler polynomial. So to factor that one there, I am looking for two numbers that multiply to a times c, which is negative 18, and add to my middle number of negative 7. So to help me with that, I have my factor pairs of negative 18. I know since I multiply to a negative, I have to have a positive and a negative, positive and a negative. And since I add to a negative, my bigger number has to be the negative number. So I can see that my solution is right here, 2 and negative 9. So positive 2, negative 9. Just do a quick check. Positive 2 times negative 9 is negative 18. Positive 2 plus negative 9 is negative 7. I'm good to go. So I'm going to factor with the box method. So I put my first term, 6d squared here, my last term here, and then my factor pairs in any order. Doesn't matter what order you do them in. Okay, now I just factor by GCF. So in this column here, the GCF between 6 and 2 is 2. Between d squared and d is d. So I know that 2d times 3d gives me my 6d. Okay, in this column here, I'm going to factor by a GCF. So the greatest common factor is 3. But since this guy is negative here, I'm going to factor out a negative 3. So let's just check. Negative 3 times 3d is negative 9d. Good. So I'm good on both of these. So 2d times what number gives me 2d? Well, that's just a 1, a positive 1. So that's good. And negative 3 times positive 1 is negative 3. So I know I factored this correctly. So it factors as 2d minus 3 and 3d plus 1 equals 0. So I'm going to set each factor equal to 0. And I'm going to solve for d, but then I'm going to make my substitution at the end. Okay, so over here, I'm going to add 3 to both sides. So I get 2d equals 3. And then divide both sides by 2. And I get d equals 3/2. Over here, 3d, I'm going to subtract 1 from both sides equals negative 1. And then divide both sides by 3, and d equals negative 1/3. Now that's the solution for d, but remember we didn't start with d, we started with x's. So remember up here where I said x, d was x plus 2. Now all I'm going to do is substitute instead of a d, because I know that d is x plus 2, I'm going to write this as x plus 2 equals 3/2. And x plus 2 equals negative 1/3. So to solve for x, I would just subtract 2 from both sides. So x equals, and we can do this on our calculator. So you can do 3/2 and then take away 1, and that's a negative half, negative 0.5. So I know x equals negative 1/2. And then over here, I'm just going to subtract 2 from both sides. So I get negative 1/3, take away 2. That's negative 2.3 repeating, and I'll change that back into a fraction and say that it's negative 7/3. So my final solution is for x, not for d. So this would be my final solution. Okay, let's try this question here before we do some word problems. I want to create a quadratic that has roots of 3/2 and negative 2. So my tip for you here is to work backwards, okay? We're going to start at our x-intercepts, we're going to go to our factors, we're going to multiply and turn it into a quadratic. So our x-intercepts in this question are 3/2 and negative 2. So I've done my x-intercepts. Now I'm going to change them into factors. So over here, I'm going to multiply both sides by 4 because factors don't have fractions. So I have 4x equals 2, 3, and then subtract 3 from both sides, and I get 4x minus 3 equals 0. Over here, all I have to do is add 2 to both sides. So now I've got my factors. Step 3, I am going to multiply. So I'm going to do 4x minus 3 multiplied by x plus 2. So applying the distributive property, 4x times x, 4x squared. 4x times 2, 8x, negative 3 times x, and negative 3 times positive 2. Grouping my like terms, 4x squared plus 5x minus 6. So this is a quadratic that has those roots of 3/4 and negative 2. Okay, I want to do 2 word problems with you. So in this first word problem, we have a water slide, and it ends with the slider dropping into a deep pool of water. So imagine you're going down the slide and you kind of do a little dip up in the air, get some air, and then you land into the pool. Well, that pathway after you leave the water slide is modeled by this equation, where h is the height above the water and d is the distance from the slide. Okay, I want to know what is the horizontal distance, so what is my d value? The slider travels before dropping into the pool after leaving the lower end. So when I drop into the pool, my height is 0, and I want to find my d value. So really, that's asking you to find the d-intercept of this function here. So I'm going to set my height equal to 0, and then I'm going to solve for d. So I have negative 1 over 6 d squared minus 1 over 6 d plus 2. Now remember I told you guys you can't have fractions when you factor? Well, I have some fractions here that I need to get rid of. So what I'm going to do, since I'm all dividing by 6, I'm going to multiply everything by 6. But I'm not just going to multiply it by 6 because I notice that my leading coefficient here is negative. I'm going to multiply everything by negative 6. Now, because this is an equation, we need to maintain balance, and I'm multiplying every single number by negative 6 to maintain that balance. So I have negative 6 times 0, 0. Negative 6 multiply by and divide by negative 6, I'm left with positive d squared. Multiply by negative 6 and divide by negative 6, I'm left with 1d, and negative 6 times 2 is negative 12. Okay, so I have a nice quadratic to factor where a is 1. So I am looking for 2 numbers that multiply to my last number of negative 12 and add to my middle number of positive 1. So remember, if I multiply to a negative number, I have to have 1 positive and 1 negative. And if I add to the positive, I know that the bigger factor is positive. So the 2 factors of 12 that are 1 apart are 4 and 3. So it's going to be 4 and negative 3, 4 and negative 3. But again, always check. Positive 4 times negative 3 is negative 12. Positive 4 plus negative 3 is positive 1. Those are the correct factors. So I put them in here. And I have the only way to get d squared is d times d, and then put in positive 4, negative 3, or vice versa. So once I have the factors, I will set each factor equal to 0. So subtract 4 from both sides, add 3 to both sides. Here I get d equals negative 4, and here I get d equals to 3. Now, d was the distance, and I can't have negative distance. So this is not a solution, and we use that big fancy word extraneous. Extraneous root means it's a solution to the quadratic, but not to the word problem, because I can't have negative distance. So this is my solution. So let's just look up here for my units, and I am talking, did we have units? Let me just see. Feet, both in feet. There we go. So he or she is 3 feet from the slide when they hit the water. Okay, one more word problem, and then we'll be done. So suppose the length of a rectangle equals to twice the width, 2 times the width, and its area equals 32. Find the dimensions of this rectangle and the perimeter. Okay, let's draw a picture. So drawing a picture, I know that my length is 2 width. So I'm not going to use length, I'm going to use 2 width. And then of course width is just width. Okay, now let's go to my area. So my area is length times width. So length, which is 2w, times width, which is w, equals 32. So 2w times w is 2w squared equals to 32. Now, at this point here, there's a couple of ways of solving it. You can solve it using the square root principle, or you can solve it by factoring. I'm going to solve it by factoring. So I'm going to subtract 32 from both sides. So I get 2w squared minus 32 equals 0. So remember I said the very first thing you check for is greatest common factor, and this in fact has a greatest common factor of 2. So 2w squared divided by 2 is w squared. 32 divided by 2 is 16. That's just a difference of squares. So I can further factor that. So square root of w squared is w. The square root of 16 is 4. Add one set, subtract the other. Okay, so I'm going to set each factor equal to 0 and then solve each factor. So here I'll divide both sides by 2, and then I end up getting w plus 4 equals 0. Subtract 4 from both sides, I get w equals negative 4. And here I will add 4 to both sides, and I get w equals 4. So I can't have a negative width. That makes no sense. So since I can't have a negative width, again, this is an extraneous root. So an extraneous root. So this tells me that the width is equal to 4. So I know that the width is 4. So let's go into our diagram here. So I know that this width is 4 centimeters and 4 centimeters. And then the length is 2 times the width, which would be 8 centimeters and 8 centimeters. So it says find the dimensions of this rectangle and its perimeter. So the dimensions are 4 centimeters by 8 centimeters. And you can see 4 times 8 is 32, that works. And then the perimeter, we're just going to add them all up. So 8 plus 4 plus 8 plus 4. So 8 and 4 is 12, so that's halfway around. So I know doubled is 24 centimeters. Okay, so hopefully that made sense, this solving business. We have a student that says to the teacher, wait a minute, you knew X was 7 the whole time and never said anything? Thought that was a pretty cute cartoon. You guys can do practice 1 to 7 in my notes and then move on to the textbook questions as you need them. So the first section is the solving questions, and then the second section is the word problem section. So I hope this video helped, and I look forward to seeing you for the next one.